Hi, and welcome everybody to this Affecto Next Generation Data Warehousing webinar. This time we will be focusing on appliances and their part in this architecture. Present here is myself, Björn Runarnes. I'm a chief architect with Affecto, and next to me is
Espen Jure. I work as an advisor at Affecto, and I've been working with data warehousing and integration for 13 some years.
Good. Today's agenda, we're going to look at the architecture and some pains and gains. Then we're going to look at appliances, and of course, in this respect, we are looking at data warehouse, business intelligence, business analytics appliances, the whys and whats, and in the end, we will go through some customer stories. When we last year started this Tear Down the Data Warehouse initiative, we promised that doing things right with the new tools, you could get in the order of 100 times faster response, 50% less operational cost, and at least 30% shorter projects, and both more efficient and also taking away some of the time lags that are time thieves in a project phases. We're going to go a little bit deeper into that now and see that so far this has been the best practice.
And this figure illustrates the existing more or less standard architecture of data warehousing. On the left we have the source systems. Then we use some sort of ETL tool to load a stage layer, then possibly through an enterprise layer into data marts. And we then run all kinds of analysis and reporting against the data marts. I mean, most of you recognize this because this is what we have been doing for 10, 15 years. So what is the challenge of this kind of architecture? I guess you have all met some sort of challenges. The typical are performance. They give a relatively said poor query performance. The query performance was very good when you had 1 million rows and so on, but as volume started to grow, the performance is not good enough anymore. As well, when the volume grows, we also suffer long data load windows, and we have issues making the load window in the morning. Also, we are pressed to do more than daily loads, so the refresh rate is, for business, too rare. The time to market is a continuous pain. The projects take too long to deliver, which makes the backlog fill up. Maintaining the existing code structure and so on is a pain, and we end up with technical debt. Things we wanted to solve, but we haven't got time to solve. This again also makes the solution cost too high because the solutions are too complex. We're using sets of tools that are not integrated. Both new and old code are often poorly documented. And we also sometimes suffer from outdated architecture and legacy solutions. All of the previous issues also have a tendency to sum up to bad data quality and increased risk. Businesses do workaround using Excel sheets. You create temporary solutions, which then tend to be kept alive. Manual workload. Yeah, this is what we often see. Now, the small figure in the center is Affecto's suggested solution to at least some of these problems, hopefully most of them. We'll go into this figure in detail just now.
One of the key components that we have investigated and found necessary in this architecture is a data virtualization layer. We will speak in more depth about that in an upcoming webinar on November 4th. So please join us then to hear more about data virtualization. But in brief, we can say it's a layer that represents itself as a database to the users. You can put access rights in there. You put business logic in there, and then it will connect to the sources, apply the business logic, and present the joined and common data out to the end user. Feeding this can be any type of system with structured, semi-structured, unstructured data. It can either work as a layer right on top of the old warehouse or from any other source. It all can directly connect to the data virtualization layer. In here, you see what we have the old ELT, the old ETL process has been changed to ELT to improve this. And one of the reasons is that all of this can go faster if you have the right layout on your machinery underneath. We'll come back to that.
Yeah, and for those who don't know the difference between ETL and ELT, ETL stands for extract, transform, load, versus ELT, which is extract, load, and transform. ELT performs most of the load on the databases itself.
The data virtualization layer also then can, present itself to the different user requirements, and is great for doing sandboxing and other prototyping environments. Don't forget your MDM solution. When you're going to move data quickly, join data quickly, it's important to have a good grip on the master data. If not, you will have a lot of mapping to do. For anything that you want to do, see the old style persisted way through the data warehouse, you can today use data warehouse integrated development environments that will improve the development time by 5, 10 times, sometimes even more. So we will have another webinar on that on November 20th. So please come back for that. Today, appliances, and this is where the ELT, doing most of the transformation on the database really applies. With the right appliance, you can improve this by a magnitude or more. So we will come back to that. Hadoop, as a data lake, sort of a repository for all types of structured and unstructured data, becomes a layer often in front of the data warehouse for the areas where that sort of file system is good. Then we will look at appliance. What is it? Actually comes from the kitchen, a stove, a refrigerator, a dishwasher. They're all appliances. Specialized, built for a purpose, complete and easy to use, standardized, and reasonably priced. And here is a collection of different types of appliances that's in the market today. All of them, most of them, complete end-to-end solutions for their part of the job. Why is this important? Well, this is a CEO study from one of the big vendors showing that the technology factor's importance in shaping the future of business has quickly risen. So from less than 10 years, it's gone from 6th place to the 1st place. And had stayed there now for since 2012. So it's important, and many of us have lived long enough to remember that the old film, the old record, the old book, all these things have gone away. I haven't seen a checkbook for 25 years. So it's important to be on top technologically to be able to follow the market. In the area we're talking now with data warehousing and reporting, there are several reports that focus on why and how you need to do changes, and the top 5 or 6 usually is scaling, query performance, data load performance, work windows, self-service reporting, etc., etc. And they all pretty much agree, what are the 5, 6 most important areas. So to address this,
we are trying to look at solutions at the different factors which are an issue with an existing technology and existing architecture. First of all, looking at the solution cost.
In today's environment, we have lots of different hardware and software working together to give us what we need. For those of you that work in this area, you know all the intricacies of changing a software version or putting in a new SAN environment or something like that. So for those of you that don't know it, we'll skip it. For those of you that do know it, you know the hassle. So the appliance is trying to do this to that situation, and taking all that complexity of joining the different technologies together and giving you one box with everything complete in it. And some of these appliances even can do analytics inside. So you also can take the analytic load out from the different end users and put it in the database. So with Andy Warhol, the less is more is back in fashion.
The performance is also an issue in the existing architecture. This is an example of an IBM Pure Data system for analytics, also known as Netezza. The reason why we're using examples from this architecture is that Bjørn Runar and myself has most of our experiences on this appliance. We also have experience from other appliances, but we're using this as an example. The thing is that an appliance has optimized hardware for performance. It's built from the bottom up with speed as a focus. It has dedicated disks inside the appliance itself, so you don't have to have sounds and you don't need to keep additional hardware for that. It's also built with very, very high performance networks inside, and they're also resilient. They are duplicated. Everything is duplicated and triplicated and whatever. So it is built for performance, and if you test it, you will see that it actually does perform very, very well. So typical performance we have seen in our examples is that just using ordinary relational connections, you get at least 2 to 4 times the speed of an existing solution. Using a direct loader, which is a bit more hassle to use, but it will give you between 10 to 75 times the performance at least. And I've seen this regularly, so it's not a once in a lifetime example. This is what you usually see. If you use, as Bjørn Runar recently told us, ELT instead of ETL, so you use push logic down into the database, you can see performance increase for operations upwards to 30 to 200 times the speed. I've seen performance about 1.5 million transactions each second. So that's give you an image of how fast this actually goes. Query performance. Query performance is definitely best on big queries. You will see some performance increasement on smaller or mid-sized queries, but it's when you come to the really big queries and large data volumes, you will see the big increases. I've seen queries running against 2 billion rows. That's 2,000 million rows. And it returns in 10, 12, 15 seconds.
Just the other day, I heard Nielsen, the Nielsen Bureau, do a presentation on their appliance and how it performs. And they said that in the biggest table they have in their warehouse now is approaching 800 billion rows in one table. And they can query it, and some of the queries will return in less than 5 seconds. 90% of the queries will return in less than 30 seconds. And that is on 800 billion rows. It's you can't even imagine it.
Okay, to sum it up, the sweet spot of an appliance is loading huge tables. Playing around with huge data volumes, adding columns, changing data, doing loads inside the database, querying those same big volumes. In addition, if you can do in-database analytics, that's really performance increase, because then you do the analytics inside database instead of retrieving data and doing it outside. Also, we see in database geospatial, that's analytics on geospatial data, performs fantastically.
A side effect of this is that the whole process of doing analytics is dramatically reduced. Normally, someone that is wanting to do an analysis and can't bring out all the data because it's too much, first have to sample the data, find a statistically correct, part of the data to take out. Then they have to move it across the network to their personal computer or whatever, trying the models and doing it over and over to get it right. And all this takes a lot of time. So it reduces effort. In the drawing here, you see that it seems like a 50% reduction, meaning that you will have twice the efficiency. We have heard clients say that they have 10 times the efficiency on their analytics these days, and that alone is worth the whole cost of the appliance. So the message is: do it simpler, do stuff where the data is, don't move them, keep them secure, understand who's using them and for what reason, and make all the results be put back in the database, in the warehouse, where everybody can reach them and benefit from them.
Time to market, as we have said, is returning pain with existing architecture. Where can you get results using an appliance for that issue? First of all, let's say appliance is not the main solution to the time to market problem, but it does help out. Why and how? Well, you can simplify data modeling. You don't need that complex models. The ease of creating new databases, duplicating them, duplicating data, triplicating them, whatever you need to test to develop, it's very fast, very easy. Also, testing is tremendously fast, so you can test and develop on live data. And that is, you get a lot of improvement due to improved performance. In addition, you can make more or less on-the-fly POCs, show the business results on live data before you go back and tune the solution some more.
Then we will look at a couple of customer stories. The first one is from a fairly large company. It's called DNV GL. It's a current merger between the Norwegian company Veritas and the German Germanische Lloyd. Spread all across the world, and they have seen that they have been in need of enabling their BICC to perform better and be less dependent on bottleneck resources, DBAs and other technical resources that are hard to get at. So they decided to go the appliance way, and unfortunately, this is, for copyright reasons, this is an original slide in Norwegian. But for those of you that don't understand that, it generally says that analysis that used to take 3 to 8 hours now can be done in less than 3 minutes, and they're now able to do analysis that they never thought was possible. And also, instead of now exporting the data, they just work interactively in the BI tools, and this has caused them to to see new opportunities and strengthen their market position. If you look at the bottom here, you see the name Christian Ramsrud. That is the person in DNV GL that has originally done this presentation. On the ETL side, they see great improvements in load time. For example, their financial consolidation, which is, of course, as a process that requires a lot more than the data warehouse, but they have been able to decrease it from 90 minutes to 15 minutes. And what that is something they want to do, 6 to 8 times every day for some time. That is really a dramatic improvement. They have other tests that show even better improvements, but they've also experienced, that to get performance improvement, to get real performance improvements, they need to do some redesign in their ETL jobs and in their data models to take advantage of the new platform. A few more numbers, like Espen mentioned, it's great for working with geospatial data, and this appliance has created sort of a new possibility of cooperation between the GIS team and the BICC, and they can work with much bigger data volumes, and they've also here seen improvements in analysis from 8 hours down to 2.5 minutes. I have myself witnessed in another POC that loading and transformation of GIS data went from 2 hours to 11 seconds. So this is a general truth about this kind of data. Same thing applies to statistics, and many of these appliances can run several types of statistical tools like SAS, R, SPSS, etc. And then you run the functionality directly in the database, making the process simpler and much quicker. Another client that just has started the appliance way have them in their data room now, and it's just accelerating the project. They have picked this, because they need to improve load times. They don't want to have to do tuning and refactoring as they grow. They want to address response time, drop aggregates to have simpler data models, etc., etc. So pretty much follows the story that Espen has been addressing through his presentation here. So they have a long list of requirements, as also did DNV, and we would be more than happy to help you, assess what kind of appliance could meet your needs. So please take contact if you're thinking along those lines.
So, what does the experts say? TDWI states that if you're still on a SMP platform, which is a normal database platform, you should actually make moving to a massive parallel processing system a priority. You should consider distributing your data warehouse architecture.
I think this will link back to the webinar that we're going to have on the 4th on data virtualization, where distributing your data warehouse architecture would involve leaving data at different zones in different tools that are optimized to treat that type of data, and then bring them together as a logical data warehouse in a virtual environment.
Yeah. And why are they saying this? I mean, reasonably, they have seen the same kind of tests, same kind of results as we are, and it's quite obvious that you should take these kinds of effect and speed gains into your organization.
Especially as we, in these sort of big data times where volumes of data are increasing, faster than we can understand. We have to change our way of doing things. We cannot move data to where we want to process them. We have to move the processing to where the data already is, because there's too much of it to move.
Yeah. And Gartner also agrees. They are stating that by 2015, 15% of organizations will modernize their strategies for IAM capabilities, and exhibit 20% higher financial performance than their peers.
So I think what Espen says here means that we will all have to change our data warehouse strategies. So the question is really, do you want to do it while you still have control, or do you want to wait until you are forced to do it, and where you're sort of caught up in the wave of action? So we would certainly advise you to start working on this before the problems become too massive.
Yeah.
With that, we have
time for questions.
Come to the end. Yes.
Yeah.